Few days back, one of my classmates posted a problem related to geometrical construction. The solution is, of course, to take a piece of paper, pencil, geometrical compass box, and then draw the geometrical figure. I decided to use a computer application which I recently came across. Here is the problem. On the right side is the picture, and on the left side are the list of problems. Construct the geometrical figure. Opposite sides must be parallel. The figure may be rectangle or parallelogram. Also, the angle need to be approximately 30 degree, not exact. Draw the same figure at 1:2 scale, basically at half the size. Draw the same figure at 2:1 scale, basically draw it at twice the size. Draw and measure the diagonals in all the case. Now the conditions are only geometrical rules and normal instruments needs to be used. Each and every point and line needs to be constructed geometrically. I'm using software by the name of GeoGebra Geometry. It is free. Let me do the initial setup for doing this construction. After that, I'm going to create first a point. Okay. Now, through this point, I need to create a line. Actually, you can create many lines if you know your geometry. But I need to create one specific line, approximately horizontal. So I will need 2 points, 2 distinct points, 2 points away from each other. Yeah, that's it. A and B. Now, I really don't need B. I needed it only for construction. So I'm going to make it invisible. Next, I need to create a ray starting from point A. This ray should be approximately at an angle of 30 degree with the line. Okay, you don't need to be exact. Now, I really don't need that point C, so I'm going to make it invisible again. Next thing is, I need to create a segment of unit 40. The best way to do it is to create a circle with the radius of 40. So with A as the center and with 40 as radius, here is the circle created. Now this circle is going to intersect the ray and the line at 2 points. Let's mark those 2 points with the help of intersect tool. This is point D on the ray and this is point F on the line. Now we are going to create another ray. Okay, we need this ray to create another segment of length 30. So this ray can be approximately at 90 degree to the first ray. Now from point A, we create a circle with radius 30 and then we mark the intersection point between this smaller circle and the newly created ray. Now that's our point H. Now before I go to the next step, I will go ahead and change the thickness of rays and circles from thick solid line to dotted lines. Now while doing this geometrical construction, I have created a lot of points, lines and curves to guide me. I will be making further such guiding elements. If I do not make them look different now, then very soon I will lose track of what is the main geometrical figure and what these points, lines and curves are. Now in the next step, I will draw parallel lines. One will be parallel to ray AD and will pass through point H. Second will be parallel to ray AH and will pass through D. I will mark the intersection point of these two lines. Remember, two lines always intersect at one single point. Now with these, I have got all the 4 points needed to complete the quadrilateral. I will go ahead and make both solid lines to look dotted lines. After locating all the 4 points, I am finally in the position to draw my quadrilateral. Activating polygon tool, now I complete my quadrilateral. Immediately, I will now make all construction lines and points invisible. This will make my drawing of quadrilateral a bit clear and loud. Now let's find something about the quadrilateral which I have made. So using the angle measurement tool, I will measure the interior angles of the quadrilateral. Okay, here it is. Now this is a good time to create the two diagonals. So simply using a segment tool and selecting the two diagonal points, I can create my two diagonals, and using another tools which measures the length of the segment, I can find out the length of my diagonals. Now looking at the angle measurements, it looks like I have created a parallelogram. Now why is it so? See, first, opposite sides are parallel by construction. Second, opposite sides, they are different in length but they are congruent, equal to each other. I mean the opposite sides. Third, opposite angles are congruent. They are not 90-degree right angle, but the opposite angles are congruent. So this satisfies the definition of a quadrilateral called as parallelogram. So I have made a parallelogram. Now let's measure out of curiosity the angle made by the quadrilateral with the horizontal line, and it comes out at around 25.8 degree. And with this I am able to complete the parallelogram given in the problem just by using geometrical principles and geometric tools. Remember, each tool which I have used can easily be reproduced using pencil, paper and geometrical instruments used by school children. Now let's redraw the same parallelogram at the scale of 1:2. I mean at half the original size. Now I will mark a point J on ray AD at some distance away. Now watch this step clearly. I am making another point ahead of J, which is at the same distance and direction as point D from A. Similarly, I will mark another point from J, which is at same distance and direction of point H from A. Now, this step actually begins creating of quadrilateral at half the size of the original. Mark the midpoint using perpendicular bisector tool. Then we mark the intersection points K and L. Now, before we move ahead, let us convert the construction lines into dotted lines and make them disappear. Now we mark two parallel lines and mark the last point needed to complete the parallelogram. All 4 points are now successfully marked. We are ready to make our figure. Let us convert some more lines into dotted lines. Technically, we call such lines as construction lines, and they are never shown as solid lines. Finally, we create our parallelogram figure at exactly half the size or scale of 1:2 successfully using original parallelogram as the source. Now let us show the angles and also the length of the sides. Now simply by looking and comparing, we can say the newly constructed parallelogram is at the scale of 1:2 or half the size. Now let us mark the diagonals and show its lengths also. We can also compare this with length of the original parallelogram. Finally, we make all the construction points and lines invisible and color the new diagram a bit different. And that's how we complete the drawing of a quadrilateral or a parallelogram at 1:2 scale or half the size of the original. Now we are going to again draw the same parallelogram but at the scale of 2:1. That is at twice the size of the original. Again, our source of data will be the original diagram. This time, I would like you all to watch and observe and make some meaning out of it. Enjoy, and if you all like it, then share and subscribe.